In pre-calc 1, we were giving this equation y is equal to 2 over x. Now, we know in pre-calc 1, good morning, that this is a rational function. And this is what the graph looks like. It's a rational function in which we have a horizontal asymptote at 0 and a vertical asymptote at 0 as well. But really, what this is a hyperbola. This is a hyperbola that has been rotated 45 degrees. And so let's go through it as a hyperbola. That's what it is. It's really, truly a hyperbola. And your y and your x, where x is 0 and y is 0, those horizontal and vertical asymptotes are really the asymptotes through the box. So really, what we had in pre-calc 1 was a hyperbola with a rotation of axes. Sweet, huh? You're like, no, it's not. This is pretty delicious. So if we go from that equation y equals 2 over x to a hyperbola, then we have to talk about the rotation of axes. Notationally, what we usually note is our rotated axes will be primes. So if this is my x-axis and this is my y-axis, and if I rotate it through some angle, so I'm going to rotate this some angle theta, then this new axis we usually label as x prime, and this new y-axis after the rotation is usually labeled y prime. We may also see these with hats. We may also see these as labeled y hat and x hat. And you may also see these labeled as capital Y and capital X. So those are the different ways in which you may see that. If you see that in the book or on the homework, it just means we are talking about a rotated axis. Okay? Any questions so far? All right. So the other part of this information is, let me just erase this. Is if we have some point on the original graph right here, this point on the original graph is the point P, which is x and y. So that point on the original graph is px comma y. Now that point is still in the same position after the rotation. It's still in the same position after the rotation. The difference is the triangle that's built on the original looks like this. The triangle that's built on the rotated axis looks like that. So if we have this original angle here, we'll call this alpha. Then over on the new axis, that angle that is formed between the rotated axes and that R value is no longer alpha, that is phi. What I do know, though, is that alpha is going to be my angle of rotation, which is theta, plus phi. When I have rotated my axes, I call this point still point P, but you may see it as P x prime y prime. And that's referencing off of the rotated axes, but it's in the same place. Yes?
So theta is the old angle, phi is the new one, and alpha is what comes together?
So the question was about the angles. So if I have the original angle in terms of where my point is right here, the angle that is formed between the x-axis on my original graph, the angle that is formed between my original axes and its point, that radius going to it, is alpha. The rotated amount is theta. So theta is the rotated amount, and then phi is now the angle that is formed between the new axes and the point, which is still in the same spot. So that is this part right here. So that's where phi is. How are we doing? We're doing okay so far? Yes?
Just to clarify, the P, X prime, and Y prime is the representation of the new.
Yes. So the question was about the p, x prime, y prime. The p, x prime, y prime is still in the same position as it was before on the original one, but now we're going to reference it off of our x prime, y prime axes. So that's why we label it as p prime, p, x prime, y prime, or hat you may see, or just capitals you may see. Still in the exact same position. So, like I said before, if this was the angle alpha, alpha is phi plus theta. Theta is the amount that we rotate the axes. So when I see theta, that is the rotation, how far you rotate the new axes off of the original. And then phi is the angle that is formed based off the rotated axes out to the point and off of the radius. Questions? Does anyone have any kind of questions so far? So we're going to use these formulas here to get a rotation. So x initially, then when we see x here, this is x referencing off of the original point. So x is going to be x prime cosine theta minus y prime sine theta. And y is equal to x prime sine theta minus y prime cosine theta. Now there's a proof in the book if you have nothing better to do Friday night and you're like, man, I need to sleep. There's a proof in the book on it. So if you want to know the whys, lovely proof in the book. But we don't want x and y, what we want is x prime, y prime. So if you remember from your pre-calc 1 class toward the end, you learned matrices. Do you remember matrices at all? Nope. If you didn't, that's okay if you don't remember matrices. We're not going to do matrices in here. But if we use matrices to solve for x prime, y prime, which is what I want, so I set up the matrix where I have cosine and sine, sine and negative cosine. These are multiplied by our primes. If I then take the A inverse where this part is A, take the A inverse of both sides, I ended up solving for y prime and x prime, which is what I wanted in the first place. So we get these two pieces of information. I have a x and I have a y, but I also have replacements for x prime and y prime. So these two sets of equations you will need to know to be able to do these rotations of axes. So I'll give you a moment to write these down, and then we're actually going to go through some examples. If we go back to our example where I have y is equal to 2 over x, and I multiply both sides by x, so I end up with this equation right here. And for right now, I'm telling you what the angle is. So just accept that that's what the angle is. In a moment, we're actually going to find the angle, but for right now, just accept that's my angle. Then I replace x here with x prime cosine pi over 4 minus y prime sine of pi over 4. And then I replace y using the same kind of thing as I replace y with x prime sine of my angle plus y prime sine of my angle. And what I'm using is, I'm using these equations right here. That's that equation, and that's that equation. So all I'm doing is plugging in the information that I know. And the reason I'm doing all of this is so that I can do a replacement for this part. So when I'm doing a rotation of axes, my first step is to do these replacements after I've found my angle. So actually, my first step is find the angle. And the reason I do this, the whole reason I do this rotation of axes is because I'm going to have for the first time this xy in there, and I can't have that in there, so I don't know how to graph that, especially if I'm doing conics. Do you have any questions for me so far? So once I've got these two values for replacement for x and y, I put them back in there. So this replaces x, and this replaces y. What kind of questions do you have for me so far? Everyone's cool with what we're doing? Is anyone lost, dazed, or confused? Please let me know. All right. So then you'll notice that on this part here, this part and this part are a difference of squares. Because they're a difference of squares, those two multiply in to here. That's what that becomes when you do the difference of squares. If I multiply the square root of 2 times the square root of 2, I'm going to get 2 over 4. Lauren, you got that look at like, I don't know what she's doing. Okay. Okay. How are we doing? Okay. So now I go ahead and distribute that 2 over 4, which is 1/2. So on this, I just distributed this 1/2 through here and here. That's all I did on that step. So from here to here, that step, all I did was multiply that 1/2 through on each one of those terms. On the next step, from here to here, is I just multiplied everything by 2 to get rid of my fractions. When I multiply everything by 2, then I'm going to get x prime squared minus y prime squared is equal to 4. And then I divide each term by 4 to get it into standard form. So what kind of questions do you have for me?
Is that as far as we're getting?
That is, yep. And the reason that is because at this point, I'm going to go over here and I can graph it on the rotated axes. Here's my original axes. My rotation is a 45. So here is where x prime went to, and here is where y prime went to. So from my rotated axes, I'm going to build a box. And how far out in each direction do I need to build my box? 2. So on my rotated axes, I go out 2 in each direction, and I build my box. Not a very well-built box, but there's my box. I know that within my box, I have to have asymptotes that go through the center and corner to corner. I also know that in my rotated form right here, my y is the positive. Since my y is the positive, then my transverse axes, or the axes I'm going to hug, is going to be along there. And there's my graph.
How is the y positive then?
The x is positive.
The X is, you said Y,
Oh, x, sorry, x is positive.
so if the Y was positive, then it would be on the other.
Yep, absolutely. And I can tilt mine all I want, but you know, it's not going to tilt it for you all, because I can tilt mine for me and I can say, oh, there it is. So you all just kind of have to turn your head like this, and you'll be able, there you go, just like that. So everyone turn your head to the left, and then you can see it. Yes?
When you're kind of about the difference of squares, will that always like hold true for when we're kind of simplifying the left side?
So the question was, is this always going to hold true? This difference of squares is going to shake out like that? And the answer is yes. And the whole reason that that works out is because we're going to be, in a moment, we're going to try to eliminate the xy term, because these will have xy terms. So it will work out. Okay, anything else? Any other questions you may have for me? Yes?
So you said it was a rotation of 45 degrees. Is that just because it's the square root of 2 and it's square root of 2?
Well, we're actually going to do the rotation axis. We're going to do the rotation angle in a moment. So at that point, I was just asking you to do a leap of faith. In a moment, we're actually going to go through the entire thing with finding the rotation as well. Anything else?
So these are not on the test?
No, because these are long.
Are they on the final?
No, they are long. It's like proof by induction. Those are long. I mean, I can give you 2 questions in a 2-hour test, proof by induction and rotation of axes, and you might get them done. So I'm not putting them on the final. Unless you're like, man, those are the 2 things I wanted to make sure I knew. Okay. So what we're going to have is we're going to have equations that look like this. We're going to have ax squared plus bxy, and that's why we're doing this whole thing. It's because we have that bxy. If I don't have the xy term, I wouldn't do any of these shenanigans. So I'm going to have a bxy cy squared plus dx plus ey plus f. I am not guaranteed to have any of these except for the a, b, and c part. So I'll have an ax squared plus a bxy plus a cy squared if I have an ellipse, a hyperbola, or a circle. If I am missing the c part or I'm missing the a part, then I have a parabola. So again, if I am missing a c, if c is 0 or a is 0, then I have a parabola. Otherwise, if I have a, b, and c, none of those are 0, then I have an ellipse, I have a hyperbola, or I have a circle. So if I start out with x is equal to and y is equal to, and I do these replacements, which I will be doing in a moment, then what I end up with is this lovely equation right here, which simplifies into this. Please don't write all of this down. It's in your book, and holy crap, no. The important part is this. That's the important part. That's the part that's going to give us our angle of rotation. And I know that I can replace cosine and sine with cotangent. So the cotangent of 2 times my angle is equal to a minus c divided by b, where a, c, and b are coefficients on my equation. A is a coefficient on x squared, b is a coefficient on xy, and c is the coefficient on y squared. The thing that we have to pay attention to is our rotation is going to be counterclockwise. So in other words, our rotations will always be off the x-axis in the positive direction. Not only that, but our angle of rotation should also be between 0 and pi over 2. Because if you go 90 degrees, then you really haven't done much. And the same thing if you go beyond that. So we try to find angles that are between 0 and pi over 2. Questions for me so far?
When you say it's called when you're missing A or C?
It's a parabola.
Did you say angle between 0 and pi over 2? Or?
0 and pi over 2. All right. So we're just asked to find the angle. So on your homework, there's only like 6 questions. The first 2 ask you with the type of conic. The second 2 ask you for the angle of rotation, and then the last 2 ask you to actually do the rotation on it. So even though there's only 6 questions, the first 4 should be fairly straightforward. The last 2 will take you about 10, 15 minutes a question. That's why there's only 6 questions. So it'll probably take you about 30 minutes to complete the homework, which isn't too bad. You know, for homework, that's not too bad. So if we're asked to find the angle of rotation, what we know is we have the cotangent of 2 times my angle is equal to a minus c divided by b. So I start pulling off those values a, c, and b. I have ax squared plus bxy plus cy squared, and then all the rest of the stuff. So I only need to pay attention to the coefficients on the x squared, the xy, and the y squared. Which one of these would you like me to do? A, C, D? B as in boy? Okay. So if I'm doing B as in boy, the first thing I'm going to do is pull off the A. That's 7. I'm going to pull off the B, and that's negative 4 root 3. I'm going to pull off the C, and that's 3. So I'll need those 3 things. So my angle of rotation formula is equal to the cotangent of 2 theta is equal to 7 minus 3 over negative 4 root 3. So the cotangent of 2 theta is equal to positive 4 over negative 4 root 3. And so I have the cotangent of 2 theta is equal to negative 1 over root 3. So I look on my unit circle to see where my angle is equal to a negative 1 over root 3. So where is cotangent, first of all, negative? Which quadrants?
2 and 4.
2 and 4. Which one gives me 1 over root 3 in those two quadrants?
4, 5, or 3.
Yep. 2 pi over 3?
Yeah, 2 pi.
Now remember, when we are working tangent and cotangent, there are periods of pi. So once I have one angle, I slap on plus pi k, and I don't have to actually find the other one because this one does it for me. But I am solving for theta, not 2 theta. So now what do? I divide by 2. Or in other words, I multiply by 1/2 where I need to. So theta is equal to pi over 3. That is my angle of rotation. That is my angle of rotation. What kind of questions do you have for me on this so far?
We don't worry about the pi over, there's pi negative.
Because we want to have a positive rotation, we want to take the smallest one. The smallest one should hopefully be in the first quadrant. What other kind of questions do you have for me before you try these? Yes?
So, you won't really be seeing many large angles. It'll usually be like smaller than pi over 2.
Typically they'll be less than pi over 2. It should be in quadrant 1 for the most part. In this class I can guarantee it's going to be in quadrant 1. Yep. What other kind of questions do you have for me before you do your own? Yes? So the question is, will it ever be undefined? If it's undefined, that means we shouldn't have any rotation. So, no. The long story short, no. What other kind of questions do you have for me?
Yeah, what was that thing you said if C is missing, it's a parabola, and what was the other?
So if my squared parts are missing, right, that means I'm going to have a parabolic shape. So if my A or C is missing, I'm going to have a parabolic shape. Yep. Anything else? Any other kind of questions for me? Okay, find the angle of rotation for A and C, please. The angle of rotation for A and C. Taking a look at A, we pull off our A is 1, our B is 2, and our C is 1. So what we end up with is the cotangent of 2 theta is going to be 1 minus 1 over 2. So in other words, I get 0. So then I look on my unit circle to determine where the cotangent is equal to 0. So 2 theta is going to equal to pi over 2 plus pi k. Now for this class, every single one of these rotations will be about between 0 and pi over 2 because all of these for this class are conics that are centered around the origin. So even the parabolic shape will have its vertex at the origin. So in other classes, they will not be. So for us, it will be. So it makes no sense for us to really worry about the ones that are in the lower 2 quadrants. We really just want to focus on the angles that are in the first 2 quadrants. Now we divide everything by 2, and we end up with pi is equal to, theta is equal to pi over 4. So that is our angle of rotation. It's a 45. Okay? Now, my next one, I have an A that is 1. I have b, which is 2 root 3, and I have a c, which is negative 1. So I have the cotangent of 2 theta is equal to 1 minus a minus 1 all over negative 2 root 3. So I get 2 over negative 2 root 3, which is just negative 1 over root 3. And we already know what that is. It's from the previous example. From the previous example, we found theta to be pi over 3. How are we doing? So bless you, on the homework, you have 2 questions starting out for find the angle of rotation. The other 2 questions before you actually do the rotation is determine the type of conic that you have. So to determine the type of conic that you have, you're basically looking at just A, B, and C. If b squared minus 4ac is greater than 0, then you have a hyperbola. If b squared minus 4ac is equal to 0, then you have a parabola. If you have b squared minus 4ac is less than 0, then either it's an ellipse or it's a circle. So make sure you write those down on your notes. Those are your 3 choices. Either it's greater than 0, it's a hyperbola, it's equal to 0, it's a parabola, it's less than 0, it's a circle or an ellipse. Question?
Yeah, what are the homeworks on 7.5? Did you get the email? Like the numerators were both the same, like I said it was an ellipse, but on the actual notes and the Weber problem and in the book, it says that the denominators are the same as a circle.
So the question is, when the denominators are the same, it's actually truly an ellipse, but a circle is a subset of that. Just like every square is a subset of rectangles. So an ellipse is any ellipse as long as it holds true. A circle is a specialized ellipse. Cool? Okay. It's all good. It's all good. All right, how are we doing? You all wrote those down? Okay. So on the homework in here, where I'm just asking you to determine the type of conic that we have. That's all we're asked you to do. We're not doing any rotations yet. I'm just asking you to determine the type of conic. So I pulled off my A, B, and C. Which one would you like me to do? B as in boy. So I pull off my A, I pull off my B, and I pull off my C. So I'm looking for b squared minus 4ac, and then I determine what's going to happen based on that formula. So my b squared is negative 4 root 3, the quantity squared, minus 4 multiplied by a, which is 7, and then multiplied by c, which is 3. So I get 4 squared, which is 16, times the square root of 3 squared, so that's 3. So this is going to be 16 multiplied by 3, minus, and then I have 21 times 4, which is 84. 16 times 3 is 48. Is that going to be equal to 0, less than 0, or greater than 0? Because it's less than 0, this is either an ellipse or a circle. And just ellipse is fine. Because every circle is an ellipse.
It's just like one little part of the quadratic.
Yeah, it is. It's kind of like the discriminant. Yep. of questions do you have for me? All right, please do A and C then. Determine the type of conic. All right, so let's take a look at A. My A on A is 1, my B is 2, and my C is 1. So using the formula, my A is 1, my B is 2, and my C is 1. So I have 2 squared minus 4 times 1 times 1. What is this equal to?
0.
So this equals 0. So what kind is this? This is a parabola. Looking at C, my last one, A is 1, B is negative 2 root 3, and C is negative 1. So I'm going to have negative 2 root 3 squared minus 4 multiplied by 1 multiplied by negative 1. Without doing any work, I know this is going to be greater than 0. How do I know this is going to be greater than 0 without doing any work? Because this negative here turns this into an addition, and this will be positive, so I know without any work whatsoever this thing is greater than 0. So what kind is this? Hyperbola. Okay, so when I see you all tomorrow, we're going to do 3 examples of those. And we're going to do a little bit of the distance there. So before you pack up, because we do have 5 minutes, let's go ahead and start working through this.
What do you want us to do? What do you do first? What are you trying to do?
The first thing I'm going to do, the first thing I have to do, is find theta. That's the first thing I have to do, and then I'm going to use those formulas to move stuff out and replace. The reason I have to do that is because of this term, the xy term. If I didn't have the xy term, I would treat it as a regular conic.
So first you do the A minus C over D.
So the first thing I'm going to do is find theta. So find theta. All of you find theta.
A minus C over D.
Yep. So find theta, which is the cotangent of theta, is equal to A minus C over B. That is the first thing you have to do. What is it? Pi over 4? It is. I just keep using these over and over again. Yeah, but the answer will be pi over 4 because it's the exact same one as A above and the A above that. I just use them over and over again. Okay, so now the second thing I'm going to do is find replacements for x and y. So x is equal to x prime. I don't have these memorized. I'm going to have to go back up here. Way up here, cosine and then sine. X is equal to the cosine of my angle minus y prime, the sine of my angle. So x is going to equal to x prime, the cosine of pi over 4, minus y prime, the sine of pi over 4. So wherever I see x in my original equation, I'm going to replace it with x prime, square root of 2 over 2, minus y prime, the square root of 2 over 2. Oh yeah, the joy and fun never ends. And y is equal to x prime, and I think it's, what is it, cosine, sine? What is that?
I think it flip sine, x sine theta minus theta plus or minus?
Cosine theta?
Prime minus theta minus y prime.
Yeah.
For the y is?
Yeah.
So there's a minus there? I thought it was a plus 2.
That's what we're finding.
But this is y is equal to y, x prime sine theta? Is that right? Yes?
It's negative x sign. Negative x.
Uh,
Wait, that's the wrong one. I'm sorry. It's not negative.
so is it?
That's my fault, yes.
Is it y is equal to x prime sine theta y cosine, y prime cosine theta? Is it?
I think it's, y is y prime.
I'm just going to stop.